that I cover. And it has to do with absolute value inequalities and kind of writing them and how they relate to what's called a tolerance. And so kind of the generic form of an absolute value inequality is kind of going to be of this format. Okay? It's some value, absolute value of some quantity x minus some quantity, and it's going to be greater than or equal to, less than or equal to c, and some other quantity. So what I want to do is I want to show you how you can interpret graphs of this and figure out what the form actually is. Okay, so let's take a couple things here really quickly. Okay, let's say we take this graphical notation. So okay, let's say we take all the values that are greater than or equal to -4 but less than or equal to 10. If you wanted to identify the absolute or the different notations for this graph in inequality form, okay, the inequality notation is going to be -4 is less than or equal to x, which is less than or equal to 10. Okay, in the interval notation, this can be represented as a lower limit of -4 and upper limit of 10. They're both included, so they're going to have brackets on them. Okay, the final notation, or what you have to be able to manipulate in this case, is the absolute value notation. So I'm going to write that right here. Okay, so you need to be able to write this as an absolute value inequality. And here's how you're going to do that. You're going to base it off of this general form. And so your general form is x minus, and the value that's going to go right here is going to be the mean of the extremes. Okay, it's going to be the average of the critical points that are involved in this problem. So here are the extremes. Okay, so what we want to do is we want to find what is the average. What's the point that's halfway between those two? So what would you do to find the average of two numbers? You add them together and then divide by 2, right? So if we took 10 plus a -4, that's a +6. Divide by 2, we get 3. So that's the number that's going to go in this area. So it's the average. Okay, then you're going to have a symbol. So again, what we're kind of looking for is we wanted to find what value went here, here, and here. Okay, so we found the mean. We can now find the symbol that we're going to use. So in this spot right here is going to be the inequality symbol. And so now it depends on what the graph looks like. So remember, when you're dealing with enclosed or bounded intervals, you're looking at less than or equal to. And if you're dealing with the unbounded, the double unbounded intervals, you're looking at the greater than. So this one is sandwiching things between, right? So which of those inequalities are we going to use? A less than or a greater than? When we're limiting it to something in between two things, it's a less than. Okay, now, based on the grouping symbols, are we going to have an equal to or no equal to here? We have brackets as our symbol, so does that imply inclusion or exclusion? It's included, right? So it's going to have the equal to. Right? The final element that you have to enter here is called the tolerance. And this is the distance that can exist between the average and the extreme. So what is the distance between the average and the extreme here? From 3 to 10 is 7. And that should be true here too, right? From 3 to -4 also has a distance of 7. So that is the tolerance that you're looking for on those. And so these are the steps that you'll take in order to find the absolute value inequality of a graphical form. All right, so let's take another example, and I want you to just to try it on in on your own here. This time I'll open with parentheses to the outside. And let's say we're dealing with negative 10 and negative 2. Okay, I want you to see if you can find what the absolute value inequality is going to be for this information here. So you know the general form is going to fit this pattern right here. Absolute value of x minus, and it's the average. What is the average between a negative 10 and negative 2? Add them together and divide by 2, right? So negative 10 plus a negative 2 is negative 12. Divided by 2 is negative 6. So we get x minus a negative 6 becomes x plus 6. Okay, we can go straight to the symbol, or we can find the tolerance. Let's say we find the tolerance first. What is the tolerance? What's the distance from negative 6 to negative 2? 4. So that's always going to be a positive value here, that tolerance. It's a difference of 4. And then we determine the symbol. So here our symbol, or our grouping symbols, extend out to the outside. Okay? And so it's that the unbounded, double unbounded intervals. And so that's going to be representative, not the less thans, but the greater than. And will these extremes be included in the solution set? No, they have parentheses. So it's just going to be a greater than. And so this is what your absolute value inequality will look like. Right, so when you enter this online, you are going to use the vertical bar key. To you guys, it's right above the enter key. And the key looks like this. It has the backslash. And then what looks like on your keyboards, I think it looks like 2 vertical dash lines. Okay, but it's really just a single vertical line. And so hit shift. So you'll hit shift plus this, and that's going to equal the absolute value symbol. Okay. So do make sure that you're aware of what that looks like. All right, so in looking at this absolute value inequality and its relationship to this tolerance level, okay, you can write absolute value inequalities to represent story problems, which is what you're going to be asked to do in this section. Okay, so the story problems are going to look kind of like these. These are 2 different versions of a very similar type of question, and I want to talk through how you'd use absolute value inequalities to model this. Okay, so the question is, a bag of chips must weigh 1.5 ounces, right? So if they label the bag as 1.5 ounces, it has to weigh that with a tolerance of, and they give it, let's say, 0.125 ounces tolerance. Okay, so the bags can run off and be sent to stores as long as they fall within that range. So you want to write an absolute value inequality to model the acceptable weights. Okay, so if you look at the way that it's set up, it's absolute value of x minus the average. So on average, if bags are being labeled as 1.5 ounces, what is the average weight going to be for all the bags that come through? That's it, right? It's 1.5. That winds up, if that's what it's being labeled as or identified as, that's what the average or the mean has to be. Okay? Now, it has a tolerance of 0.125. Okay, and so when you're finding the acceptable weights, which ones are you finding? Are you finding all the ones that are within this range or to the outside of that range? Within. So the within or the group together is which inequality symbol? Less than, and it can include the one that's right on that very verge of not being acceptable, so it will be less than or equal to. So this would be the absolute value inequality that models this particular relationship. Okay, let's see how that would compare to the one that models unacceptable weights. And you just need to be really careful in reading the question to see which one they're asking for. Okay, so it's going to be the same setup, right? Absolute value of x minus the average weight, 1.5. You're still going to compare it to the tolerance of 0.125. But this time, you're modeling the unacceptable weight. So which bags are going to be discarded? Which bags can't be sold to a store? And they're the ones where the weight is beyond the acceptable limit So beyond means to the outside of, which represents which inequality. Greater than, and is it going to include those extreme values itself? No, because those are acceptable ones, right? So the unacceptable will just be a greater than. And so your inequality, the absolute value inequality for this, or modeling this scenario would look like the following.